Rest now, let your body grow calm, and let the quiet gather around you. Little by little, we'll drift into the deep, quiet mystery of the sea off Japan. If nights like this help, subscribe. There's a fresh one every evening. 25 degrees north latitude, 130 degrees east longitude, the western Pacific at dusk, the sky above the water still holding a last thin band of orange along the horizon, the surface below it running dark and slow in the long evening swell. A navigator reading these coordinates from a chart would find a point off the southeastern coast of Japan, not a harbor, not a landmark, but open ocean, the kind of position that exists only as numbers on a page until the water beneath it makes the numbers real. From there, the zone extends eastward to 145 degrees longitude and northward to 35 degrees, and southward again toward the Mariana Islands, tracing a rough and imprecise triangle across one of the most geologically complex stretches of seafloor the Pacific contains. The shape is approximate, the water within it is not. At dusk in these latitudes, the sea does not go uniformly dark. There is a line where the water changes, not a dramatic boundary, but a visible one, perceptible from the deck of a vessel as a shift in color and in the quality of the chop, a place where the surface seems to move differently, where the horizon mist sits a little lower and the wave texture changes as though the ocean has crossed an invisible seam. That line is where the Kuroshio Current meets the cooler offshore water to its north and east, and in the long, unhurried light of a Pacific dusk, the seam between them is something a careful observer can watch for and find. The Kuroshio runs northeastward through the western boundary of the zone, warm and dark blue, and carrying extraordinary volume, pressing against the cooler surrounding seas with a force that has no land equivalent, generating thermal gradients and turbulent surface states across a boundary that moves seasonally but never disappears entirely. It has been running this way for longer than there have been vessels to cross it. The current takes its name from its color. Kuroshio means black current in Japanese, a name given by people who worked near it and noticed that its water was a deeper, more saturated blue-black than the surrounding sea, the darkness coming from its clarity rather than its depth, a quality of exceptional optical transparency that makes the water appear to absorb light differently. At speeds typically ranging from 2 to 4 knots and capable of reaching 5 or 6 knots during certain seasonal peaks, it presses northeastward with a steadiness that is not dramatic but is inescapable, and where it meets the cooler water that lies along its northern edge, the collision of different temperatures and densities produces turbulence that is visible at the surface as a ragged line of chop and as a low, slow mist that forms over the warmer water in cool mornings, drifting in long, flat sheets across the gray surface before the day's warmth dissolves it. A ship crossing that boundary would feel it in the way the bow moved, in the change in the water's color below the rail, and in the condensation that collected on cold metal in the early hours before dawn. The Kuroshio is analogous in its force and its function to the Gulf Stream in the Atlantic, a major ocean current driven by the same combination of wind systems, temperature differentials, and the Earth's rotation that governs great currents everywhere. It carries an enormous volume of warm water northward from the tropics, moderating the climate of the Japanese archipelago, sustaining the biological productivity of the surface waters through which it moves, and generating the meteorological conditions that make the zone one of the most storm-active maritime regions in the world. The thermal energy it deposits into the lower atmosphere above it feeds the formation and intensification of tropical cyclones, typhoons, in the western Pacific, and the Japan Meteorological Agency, which has tracked these systems continuously since the modern era of satellite meteorology began, records an average of 20 to 30 named tropical cyclones forming in the western Pacific each year, many of them developing their initial circulation over the warm water the Kuroshio maintains, many of them tracking directly across or through the Dragon's Triangle zone before making landfall or dissipating over cooler northern seas. That is not an extraordinary number for the Western Pacific as a whole. It is, however, a number that places any vessel working the zone under a statistical reality that requires no embellishment. In the satellite era, the genesis of a typhoon is visible from above with a clarity that earlier generations of meteorologists and sailors did not have access to. A Japanese meteorological agency weather satellite image of the western Pacific in late summer shows the warm pool of Kuroshio-fed surface water southeast of Honshu as a slightly different color in the sea surface temperature composites, warmer than its surroundings by several degrees, a thermal reservoir from which developing storm systems draw their energy, a low-pressure system tracking over that water, given sufficient atmospheric instability and weak enough wind shear aloft, begins to organize. The cloud mass that had been loose and asymmetric begins to pull inward, its rotation tightening, banding features emerging in the outer circulation as the system draws energy from the warm surface below. On a satellite image, the change from disorganized convection to the first suggestion of a tropical cyclone takes hours. The spiral begins to form. The eye of the system is not yet apparent, but the shape is already becoming recognizable to anyone who has learned to read these images, and the forecast models are already calculating the track and the intensity, and the advisory text is already being composed. And before the satellites, none of this was visible until the system was close enough to land, or to a ship to be experienced directly. Winter in the zone produces different weather, but not quieter weather. The typhoon season recede, quit, and in its place come the extratropical storm systems that develop as cold Siberian air masses push south and east over the relatively warm Kuroshio water, generating steep pressure gradients and sustained wind events capable of producing wave heights that frequently exceed 10 meters across broad areas of the zone. These are not singular catastrophic events. They are the ordinary winter sea state of the Western Pacific in this latitude band, the condition that ships are built and crewed to manage, the baseline against which a vessel's seakeeping characteristics are evaluated. 10-meter wave heights in sustained winter sea states are a parameter that naval architects and shipping companies and maritime safety agencies have worked with for as long as there have been formal maritime industries in this part of the ocean. They are, in the plain language of ocean science, a known quantity. What makes the zone particular is not that these conditions exist, but that the convergence of factors, the Kuroshio's thermal energy, the typhoon exposure, and the geological character of the seafloor beneath, produces a combination that is found together here in a way that is not common across the broader Pacific. The seafloor beneath the Dragon's Triangle zone sits atop the convergence of two major tectonic plates, the Philippine Sea Plate and the Pacific Plate, and the boundary between them is not a stable and quiet interface. Along the eastern margin of the zone, the Izu-Bonin volcanic arc runs in a rough chain of islands and seamounts from the Izu Peninsula of Honshu southward toward the Mariana Islands, expressing at the surface, and just below it, the geological energy of a plate boundary where oceanic crust is being subducted, pushed downward beneath the overriding plate, generating heat and pressure, and the continuous release of volcanic material that has built the arc's islands and seamounts over millions of years. The seamounts along the arc are not uniformly ancient structures. Some of them are actively volcanic, their peaks below the waterline, but their activity real and ongoing. Their geological behavior determined not by the rhythm of human observation, but by the internal dynamics of the magmatic systems beneath them, which do not follow schedules or announce their changes above the surface before they have already occurred. Along the Izubonin Arc, the seafloor is not a uniform plain. It is a landscape of considerable relief, seamounts rising from the abyssal floor, submarine ridges running for hundreds of kilometers, the scarps and slopes of volcanic edifices standing in absolute darkness at depths where the surface weather is not felt in any direct physical sense, where the pressure of the water column above reduces all motion to something that is not stillness, but is close to it. A seamount along the arc might rise from an abyssal plain at 4,000 meters depth, its flanks ascending through the dark water over a horizontal distance of many kilometers, its peak still 1,000 meters or more below the surface at the point where the structure terminates. On that peak and along those flanks, hydrothermal activity is not unusual, water percolating through fractured volcanic rock, heated by the magmatic system below, rising as thin plumes of superheated fluid into the cold dark surrounding it, the plume water carrying dissolved minerals that precipitate at the boundary where the hot fluid meets the cold ambient seawater. This is a common feature of volcanic seamounts. It is also, for any vessel directly above it, entirely invisible and entirely unknown unless the seafloor has been surveyed with instruments capable of detecting it, which in much of this zone it had not been for most of the history of navigation across these waters. The abyssal plains of the Dragon's Triangle Zone sit at depths that are difficult to make intuitive. The Izubonin Trench runs along the eastern boundary of the zone, and at its deepest measured point, it descends to approximately 9,780 meters below the surface. That is a number that resists ordinary comparison. The highest mountain on Earth above sea level rises to approximately 8,850 meters. The deepest measured point of the Izubonin Trench is nearly a full kilometer deeper than that. At the floor of the trench, the pressure of the water column above is roughly 960 times the atmospheric pressure at sea level. The temperature is just above freezing. The light, there is none. There has never been any, not in the sense that sunlight reaches the bottom of shallow tropical seas. At 9,780 meters, the last photon of surface light was absorbed thousands of meters above, and the darkness at the trench floor is not the darkness of a room with the lights off, but something more absolute and more constant, a darkness that has persisted without interruption since that basin formed. The floor of the Izubonin Trench is covered with sediment, fine particles of clay, and the remains of microscopic organisms that have drifted down from the surface over millions of years, accumulating in layers whose depth records geological time with a patience that no human scale of reference quite accommodates. On the surface of that sediment, the trench is quiet. Not silent in the acoustic sense, sound travels efficiently through deep water, and the trench floor receives the attenuated acoustic energy of distant earthquakes, of shipping noise, of biological sounds from mid-water organisms above. But the surface of the sediment itself is undisturbed by any of the weather that moves the water above, by any of the storms that produce those 10-meter wave heights in the winter surface seas, by any of the thermal gradients and turbulent mixing that characterize the upper water column. The sediment surface is still in a way that the surface of the ocean above it never is. Each layer of sediment resting on the layer below it the record intact, the conditions at that depth unchanging, through the seasons and through the decades and through the human history of navigation on the surface above. The tectonic convergence that built the Izubonin volcanic arc and that continues to sustain its geological activity does not express itself uniformly across the zone. Between major volcanic structures, between seamounts and ridges, the sea floor descends to the abyssal plains where the geological character is different, quieter at the surface of the sediment, but still geologically active in the sense that the plate movement continues beneath, and that seismic events along the subduction boundary propagate through the seafloor as elastic waves recorded by instruments on land and at sea. The Philippine sea plate moves at rates measured in centimeters per year, a pace imperceptible on any human timescale, but steady across geological time, and the energy released at the subduction boundary as that motion proceeds is expressed in earthquakes that range from minor and frequent to major and occasionally catastrophic. The zone is, in this sense, not a place of geological stability that is occasionally interrupted by dramatic events. It is a place of geological activity that is occasionally expressed at the surface in ways that are dramatic enough to be noticed. The Kuroshio Current carries its warm water northeastward, not merely across the surface, but through a substantial depth range, and its influence on the ocean above it extends into the atmosphere through the thermal energy it deposits into the lower air. On a calm winter morning in the zone, when the surface winds are light and the overnight cooling has reduced the air temperature while the Kuroshio water below remains warm, fog forms over the current's warm edge, not the dense fog of a cold coastal sea, but a low, slow fog that moves across the surface in long, flat sheets, the water below it appearing gray and absolutely still in the early light, the fog itself a product of the same thermal contrast that drives the turbulence when conditions are less calm. A vessel moving through that fog in the early morning would be surrounded by near-zero visibility at deck level, while the sky above remained clear, a condition that requires careful navigation and that reduces the visual horizon to a few meters of water in every direction, the surface of the sea and the surface of the fog above it, seeming to compress the world into a small and quiet pocket of gray. The surface expression of the zone's weather is in this way connected at every scale to the same underlying driver, the warmth of the Kuroshio pressing against cooler surrounding water and atmosphere, generating the temperature and humidity gradients that produce fog and storms, and the typhoon genesis conditions that the Japan Meteorological Agency monitors across the Western Pacific each season. It is a system in the scientific sense, a set of components whose interactions produce the zone's characteristic conditions, each component connected to the others in ways that a marine meteorologist can trace and model and within limits forecast. The forecast is not perfect. The sea state that a vessel encounters on a given day in the zone depends on the interaction of factors that are individually predictable only to a degree, and the combination of factors that produces an extreme event, a very large wave, a rapid intensification of a developing tropical system, an unusual current pattern is not always visible in advance, but the physical basis of those conditions is understood, and the understanding is the product of decades of measurement and observation and the accumulation of oceanic data that now forms the scientific record of these waters. Below the current's surface expressions, below the fog and the storm formation and the wave trains generated by typhoon winds, below the thermocline where warm surface water grades into the cold, deep ocean, the zone's geological character continues, undisturbed by any of what happens above. The seamounts of the Izubonin Arc extend upward from the abyssal plain, toward a surface they do not reach, their peaks in darkness, their flanks hosting whatever biological communities the hydrothermal conditions there sustain. The Izubonin Trench receives the slow fall of sediment from above, adding its fraction of a millimeter to the accumulated record of the zone's past. The tectonic plates continue their slow convergence, storing and releasing energy in the rock at the boundary between them, the energy propagating outward in waves through the ocean and through the overlying water to the surface, that the Kuroshio warms, and that the typhoons cross, and that the fog covers in the quiet early mornings of late autumn. Sailors have been crossing the surface of this zone for centuries. The maritime routes between Japan and the Ryukyu Kingdom, between Japan and China, between the Japanese archipelago and the Bonin Islands and the Mariana Islands, all pass through or along the edges of the Dragon's Triangle Zone, and the records of those crossings, commercial ledgers, navigational diaries, official maritime documents, the accumulated administrative archive of trade and transit across these waters stretch back further than any modern cartographic designation of the zone. The sailors who made those crossings knew the Kuroshio by its behavior, if not always by name. They knew the typhoon season by calendar and by the signs that their predecessors had documented and passed on. They knew that the waters south of the Izu Peninsula behaved differently from the inshore water, that the currents were stronger and less predictable, that weather could change faster than it did closer to land, that the fog that formed over the warm water in certain seasons could close in without the wind shifts that typically preceded fog in coastal seas. What they could not have known, crossing the surface in wooden vessels and later in steel ones, was what lay beneath them in the full measure of its scale. The seamounts whose peaks sat 1,000 meters below the waterline and whose flanks descended to the abyssal plain were not charted with any useful resolution until the era of acoustic depth sounding, which came to the Western Pacific in earnest only in the 20th century. The volcanic activity of the Izu-Bonin arc below the waterline was known in its surface expressions, islands that occasionally changed their profiles following eruptions, new shoals that appeared after submarine volcanic events, but the continuous and varied geological activity of the arc as a whole was not mapped or monitored with anything like current resolution until the instrumental record of the last several decades made it accessible. A navigator working these waters in the 15th century, or the 18th, or even the early 20th, crossed a seafloor that was, from the surface, simply invisible and effectively unknown. The zone spans roughly 10 degrees of latitude and 15 degrees of longitude, an area of ocean that is not dramatically larger than some well-known sea regions, but that is, in its combination of characteristics, among the more geologically and meteorologically complex patches of the Western Pacific. The tectonic boundary below, the volcanic arc along its eastern margin, the deep trench at the arc's outer edge, the Kuroshio pressing northeastward along its western boundary, the typhoon exposure sustained by the Kuroshio's thermal energy, the winter extratropical storms moving across from the northwest. These are not independent phenomena. They are expressions of the same underlying geography, the same arrangement of plate boundaries and ocean circulation patterns that has characterized this part of the Pacific for millions of years, and that will continue to characterize it long after the current era of navigation and satellite, monitoring and scientific measurement has been succeeded by whatever comes after it. A vessel holding position at the center of the zone on a calm morning, the fog drifting in low sheets across the gray surface, the Kuroshio moving steadily beneath the keel, the sky above the fog pale and wide, would be floating above geological features of extraordinary scale and variety, none of them visible, none of them immediately perceptible, all of them present and continuing. The seamount peak 1,000 meters below the waterline, its summit invisible, and its hydrothermal activity proceeding quietly in the dark. The abyssal plains stretching away from the arc in either direction, their sediment surfaces undisturbed by the fog or the wind, or any of the surface conditions that define the morning for the vessel above them. The subduction boundary where the Pacific plate presses beneath the Philippine sea plate, the rock at the interface under pressures and temperatures that make the surface conditions of the zone, its typhoons, its rogue waves, its strong currents, seem by comparison delicate. The Izubonin trench floor, at 9,780 meters, is a specific place, not a category or a concept. It is a section of the Earth's solid surface, covered in sediment, lying beneath a column of water whose weight and pressure are measurable and have been measured. It is dark there in the absolute and permanent sense. The darkness is not a feature of the time of day or the weather or the season, but a fixed condition of the depth, unvarying, uninterrupted. A surface ship directly above it, working the zone on a clear day, with the Curcio visible along the western horizon as a line of slightly different color and slightly rougher water, is perhaps 9,800 close enough that the distance between them could be described as the same order of magnitude, and sufficiently far that the conditions at the two ends of that column of water share almost no common experience. Sailors have crossed the surface above that trench floor for centuries. Most of them did not know the trench was there, not because the knowledge was hidden, but because the tools to find it did not exist for most of the period of maritime activity in these waters, and because the depth of the ocean floor, while consequential in geological and scientific terms, is not a variable that directly affects a vessel working its way northward through the Kuroshio swell. The surface is what the sailor occupies. The surface is what can be navigated and managed and survived. The trench floor is simply what lies below, still and cold and lightless, continuing without reference to anything that happens above it, as it has continued through all the crossings that the zone has witnessed, and through all the crossings that the records do not account for, and through all the long stretches of time before there were crossings at all. Mano Umi said slowly, "It has the quality of a breath let out over water, 2 syllables, then one, then the space after." The translation that Japanese linguistic scholars have settled on is Sea of the Devil, or Sea of Misfortune, though both renderings lose something that the original holds. The character Ma carries an older meaning beneath its more common ones, a liminal quality, the word for a space between things, a threshold, a pause between one state and another. For a Japanese fisherman in a small wooden vessel preparing to work the waters south of the Izu Peninsula, the name was not merely a warning. It was a description of what the sea in that direction was understood to be, a place that existed between the known world and something beyond it, something that did not have a name, because the people who had encountered it most directly had not come back to provide one. The Izu Peninsula extends southward from the main island of Honshu into open Pacific water, and from its southernmost points on clear days, a fisherman could see the faint shapes of the Izu Islands stretching away toward the horizon. Oshima first, then Toshima, then Nijima, then the more distant ones. Beyond them, at distances that blurred into weather and open sea, lay the waters the name described. The wooden vessels that worked those routes were not fragile in the way the word wooden sometimes implies. They were built for those seas by people who had learned from centuries of loss what the sea in that region required. but they were small against the scale of what the Izu waters could produce, and the fishermen who crewed them understood their smallness with the practical clarity of people who had inherited it as knowledge from the generation before them and the generation before that. The name itself was the first thing inherited. Mano Umi, spoken before a departure in a certain direction, not as a curse but as an acknowledgement, the way a person might note the particular quality of the weather before stepping outside. It named something that was agreed upon. It placed a specific piece of ocean in a category that everyone working those coasts already understood, and because everyone understood it, the name required no further explanation. It was inherited instruction compressed into 3 characters. The sea south of here is the kind of sea that has a name like this. The name is enough. Know what the name means. What the name drew on in the deep structure of Japanese maritime culture was a much older and more elaborate set of beliefs about what lay beneath the ocean's surface and what governed what happened there. Japanese religious tradition, shaped by Shinto practice and by the Buddhism that had woven itself into it across the centuries, held water deities of extraordinary complexity. The Ryu, the dragon, was not simply a destructive creature in this tradition. It was a being of enormous power whose relationship to sailors and to the sea was neither simply protective nor simply dangerous, but something that depended on circumstances, on behavior, on the accumulated weight of respect or its absence. The Tatsu, the same creature under a slightly different name in certain regional traditions, was capable of both driving fish toward a boat and sending a storm across one. It could as easily produce a safe passage as consume the vessel attempting it. Beneath the ocean surface, according to coastal Japanese religious tradition, lay Ryugujo, the undersea dragon palace, the domain of the Dragon King Ryujin. This was not a vague or abstract belief. It was specific enough to have architectural descriptions: a palace made of red and white coral, with towers of fish scale and walls of crystal, tended by sea creatures and governed by a being whose power over the ocean was absolute. The Dragon King held the tide jewels, the Kanju and the Manju, 2 stones whose possession gave control over the seas rising and falling. In the most familiar version of the Urashima Taro story, the palace was a place a fisherman could reach and return from, changed, carrying with him something he could not put down. For coastal fishing communities working the waters south of Honshu, the existence of Ryugujo beneath the ocean floor was not a story about the ocean. It was a description of it. The palace was down there. The Dragon King was its ruler. What happened on the surface? The storms that appeared without adequate warning, the currents that pressed a vessel sideways off a known course, the sudden calm that preceded something worse, were expressions of conditions below, rather than purely atmospheric events. When Mano Umi swallowed a boat, it did so because something in the palace below had shifted. The sea that bore the name was the roof of something enormous, and what it did to vessels on its surface was never entirely separable from what was understood to exist beneath them. This was not a framework that sailors held apart from practical knowledge of the sea. The two coexisted in the same mind, without apparent contradiction. A fisherman who observed cloud formations and read them accurately for weather, who knew the Kuroshio's pull and compensated for it on a tack south, who understood the particular color of the water in certain seasons as a guide to where fish would be holding. That same fisherman also understood that the Dragon King's domain lay beneath the water he was reading. The practical and the cosmological occupied the same space and reinforced each other. When the practical knowledge could not account for what happened, the cosmological held it. The thing the instruments could not explain, the tradition could name. Chinese maritime records from the early 15th century describe the Western Pacific in terms that, while broader in scope than the zone the later name would define, overlap with it in ways that scholars of Ming Dynasty naval history have noted. The expeditions of Admiral Zheng He, among the largest organized maritime operations in human history up to that point, involving hundreds of vessels carrying thousands of people across enormous distances, documented the waters of the Western Pacific with the methodical attention of an operation for which accurate record keeping was a matter of imperial importance. The records that survive from those expeditions describe, in the region of the Western Pacific, broadly corresponding to the zone, strong and unpredictable currents, storms that arrived with minimal precursor, and notably, compass behavior that the navigators logged as irregular in certain stretches of those waters. The compass irregularities are worth sitting with for a moment, not because they are without explanation, but because of what their documentation tells us. The navigators of Zheng He's fleet were professional, experienced sailors operating with the best instruments available to 15th century Chinese maritime technology. They were not given to documenting phenomena that could be attributed to simple error. When they logged compass behavior as irregular, they were noting something that deviated from what they expected to observe, something that required notation. The explanation for what they observed, the distribution of magnetized volcanic and basaltic rock across the seafloor of the Izu Bonan Arc, was not available to them. What was available was the observation itself, carefully recorded in documents that have since informed the historical understanding of those waters. The Ryukyu Kingdom occupied the Okinawa archipelago from the late 14th century and maintained maritime trade networks of considerable sophistication and range across the decades that followed. Its traders reached China, Korea, Japan, and Southeast Asia in wooden vessels that followed routes crossing and recrossing the zone of water the later name would describe. The kingdom's trade records, the documents that survived its eventual absorption into the Japanese state in 1879, are among the most meticulous surviving accounts of maritime commerce in that part of the Western Pacific during the period they cover. They record cargo manifests, departure dates, arrival dates, trading partners, and, in the cases where these entries stop, the fact that a vessel departed and did not appear in the record again. One such vessel appears in the surviving Ryukyuan trade records as a ship of significant cargo capacity, its manifest still legible in the archived document that holds it, its departure northeast of Okinawa noted in the kingdom's trade ledger. The arrival entry that should follow it in the record does not exist. The cargo it was carrying, goods with a documented value in the trading economy of the period, drops out of the record at the same point. The vessel's name and the names of its crew do not reappear in any subsequent document that scholars have examined. The record simply continues without them, as trade records do, noting the next departure, the next arrival, the next manifest, as though the absence of one entry is simply an absence, not a mystery requiring resolution, which is perhaps the most honest thing a document can do with a gap it cannot fill. The trade losses documented in Ryukyuan records across the period of the kingdom's active maritime commerce accumulated in a way that shaped the routes those traders chose and the seasons in which they traveled. The pattern of loss was not invisible to the people managing the trade. It was a variable they worked around, the way any maritime operation works around the known risks of a particular route, by timing departures, by selecting seasons, by choosing vessel types suited to the conditions they were most likely to encounter. The zone between the Ryukyu Islands and the main Japanese islands was not avoided, because it could not be avoided. It was the route the trade required. It was instead managed, as dangerous water always has been, with the accumulated intelligence of experience and loss. The connection between trade loss and folk knowledge runs deep in coastal communities, and the fishing communities of the Izu Peninsula and the Ogasawara and Izu Island chains held their knowledge of the southern waters in a form that was neither written nor institutionalized, but was nonetheless systematic. Ethnographic researchers who documented those communities in the 20th century encountered, in their field interviews with elders and with people who remembered what elders had told them, an inherited set of practical beliefs about the waters south of the peninsula that were specific enough to be useful. The beliefs named particular grounds where fishing was productive and particular grounds where the ratio of return to risk made regular work inadvisable. They named particular cloud formations that experienced sailors read as prefatory to conditions that smaller vessels could not survive. They named particular seasons and particular lunar phases during which certain grounds were left alone. The lunar phase observation is the kind of detail that ethnographic researchers working in those communities in the mid to late 20th century found themselves pausing over, not because it was unusual in the context of coastal fishing cultures. It was not. The moon's relationship to tide and to fish behavior was well understood by working fishermen across the Pacific, but because the specificity of the grounds it applied to and the directness of the link between those grounds and the waters the name Mano Umi described suggested that the warning was not a general superstition about the moon. It was a specific navigation instruction about a specific piece of ocean, encoded in a form that lunar calendars made memorable and transmissible. An elder on the Izu Peninsula, speaking to a researcher documenting oral traditions in those communities, described the instruction as something his grandfather had given him directly, not as a story, but as a practical briefing, the way a more experienced fisherman teaches a less experienced one. The particular look of the sky east of the islands was what the grandfather had taught him to turn away from. Not the sky in general, not clouds in general, but a specific configuration, the color, the arrangement, the quality of the light on the water beneath it, that the grandfather's own experience, and presumably the experience of the people before him, had associated with conditions on those grounds that a small wooden vessel should not enter. The sky looked a particular way before the sea in that direction did what it did, turn away from that sky. The researcher noted this in a field notebook that was later preserved as part of a collection of ethnographic documentation of coastal Japanese communities. The handwriting in the notebook is careful, attentive to the distinction between the researcher's own framing and the elder's actual words, a distinction that ethnographic researchers working in the tradition of the mid-20th century were trained to maintain, and that makes such notebook more useful to later readers than sources that collapse the distinction between observer and observed. What the notebook holds is not the researcher's interpretation of what the elder believed. It is the elder's account of what his grandfather told him, recorded with enough detail that the instruction is still legible in it. The sky east of the islands, a particular look, and the learned response to it, turn away. What the grandfather knew, and what he transmitted in the form of a practical instruction about a sky configuration, was knowledge that had been distilled from events on those waters across a span of time that neither he nor his grandson could have fully measured. The instruction was old when he received it. It had been passed to him as his grandfather had passed it, probably in the same form, a description of a sky, a direction, an action. The chain of transmission between the original event and the form in which the researcher's field notebook records it is not traceable. What is traceable is the instruction itself, still specific enough after however many generations of transmission to be useful, still anchored to a particular piece of ocean, still carrying the weight of whatever happened to make someone decide that a certain look of the sky east of the Izu Islands was worth naming and remembering. The relationship between this kind of inherited maritime knowledge and the more formal traditions of Japanese religious and cosmological understanding of the sea was not one of conflict. The fishermen who knew which sky to turn away from, and the fishermen who understood the sea south of the peninsula as the roof of the Dragon King's palace were, in many cases, the same fishermen. The practical instruction and the cosmological frame coexisted not because coastal communities were unsophisticated in their thinking, but because both things were true in the ways that mattered for the life being lived. The sky instruction kept boats off dangerous grounds. The Dragon King's palace explained what the dangerous grounds were dangerous because of. Each made the other more complete, rather than undermining it. The fishing communities that held this knowledge were not static. They changed, as all communities do. The vessels evolved, the equipment improved, the role of professional weather forecasting expanded as governmental infrastructure extended into remote coastal areas across the 20th century. Younger fishermen in the later decades of that century fished grounds that their grandparents' generation had been instructed to avoid because they had better weather information, better vessels, better communication equipment. The inherited warnings did not disappear from community memory. The researchers who documented them in the mid to late 20th century found them still alive in the accounts of elders, but their practical authority had been distributed among newer knowledge sources rather than remaining concentrated in the oral tradition alone. The sky instruction survived in the field notebook. The trade vessels survived in the Ryukyuan ledger. The compass irregularities survived in the records of Zheng He's fleet. Each of these is a fragment of a much larger body of accumulated attention to a specific piece of ocean, held in different forms by different cultures across a span of centuries, during which the water itself remained constant, still pressed northeastward by the Kuroshio, still subject to the volcanic activity along the Izu Arc below it, still traversed by vessels working routes that the geography of the Western Pacific required. The dragon mythology that gave the zone its most evocative name was not a single tradition. It was a convergence of several. The Shinto and Buddhist influenced understanding of Ru as complex water deities, the specific belief in Ryugujo and its Dragon King, the regional variants that coastal communities along different stretches of the Japanese coast had developed across their own histories of working that water. These traditions agreed on the broad architecture of the belief. Dragons were real. They governed the deep water. They were capable of both protection and destruction. And the sea in certain directions was their sea, in a way that made it different from other sea. The specific forms the tradition took varied between communities and between historical periods, but the convergence on the waters south and southeast of Honshu as a zone of particular significance was consistent enough to suggest that the tradition was organized, at some level, around genuine experience of those waters. Admiral Zheng He's expeditions moved through water that the Chinese records describe with the same broad quality, changeable, strong-currented, magnetically irregular in places, without the specific dragon cosmology of Japanese maritime tradition, but with their own framework for understanding ocean forces as expressions of something larger than weather. The Chinese navigators who logged the compass irregularities in the Western Pacific were operating in a tradition that held the ocean as a domain governed by its own principles, not random, but organized by forces that human activity had to accommodate, and that careful record keeping could, over time, begin to characterize. The compass irregularities went into the record not as inexplicable mysteries, but as documented facts about a documented route, information useful to the next expedition that worked those waters. The Ryukyuan traders who lost vessels on the routes between Okinawa and the main Japanese islands were operating within a maritime culture that understood loss as a variable of the trade rather than as an aberration requiring explanation. The surviving records hold the losses with the same clerical precision they bring to the successful arrivals, a departure noted, an arrival absent, the ledger continuing. That precision is not coldness. It is the practical intelligence of a maritime trading kingdom that had organized itself around the management of risk on specific ocean routes, and that understood the gap in a trade record as information about those routes in the same way that a successful arrival was information. Something happened in the gap. The record names the gap and moves forward. What all these traditions share, the Japanese dragon cosmology, the Chinese navigator's compass log, the Ryukyuan trade ledger, the Izu Peninsula elder's account of a sky configuration his grandfather taught him, is orientation toward the same piece of water. They do not share a common explanation for what makes that water significant. They share the observation that it is significant, arrived at independently across different cultures and different centuries of experience. The explanations they developed were native to the frameworks available to them. The water they were explaining was the same water. The researcher's field notebook from the mid-20th century, documenting the Izu Peninsula elder's account, is in this sense the last entry in a chain of documentation that begins with the most ancient of those traditions and runs forward through the Ryukyuan ledgers and the Ming Dynasty naval records to a handwritten notebook in a Japanese coastal village. The traditions changed, the languages changed, the vessels changed, and the instruments changed, and the organizations that managed maritime risk changed. What did not change was the observation that the waters south of the Izu Peninsula had a quality that required naming, and that the name, in whatever language, in whatever form it took, served as both warning and acknowledgement. The notebook is preserved in a collection. The elder who described the sky instruction is gone, and the grandfather who gave it to him is many generations gone. The instruction itself, the specific configuration of sky east of the islands that meant turn away, lives now in the notebook rather than in the transmission between a working fisherman and the person learning from him. It has moved from the living tradition to the documentary record, which is how most things eventually move, which is neither loss nor gain, but simply the form that time takes, with the knowledge coastal communities carry. The water east of the Izu Peninsula continues to move. The Kuroshio presses northeastward along its edge, warm against the cooler surrounding water, the thermal boundary between them visible from a vessel's deck in the early morning as a line of chop and mist. The Dragon King's palace, in the tradition that named it, still lies beneath the surface, not a metaphor for the geological complexity of the seafloor. The tradition had no instruments to observe, but a real place in the cosmology that organized what it meant to work those waters, a real account of what was understood to be down there in the dark beneath the surface, where the sea kept its own authority. The sky east of the islands still produces the configuration the elder's grandfather named. The conditions that made the instruction worth passing down have not changed with the instruction's transmission into a field notebook rather than a fisherman's memory. What changed was who holds it, and in what form. The water itself holds nothing except what it has always held: depth, current, geology, weather, and the accumulated meaning that the people who worked its surface, in many languages and across many centuries, found they could not avoid giving it. The researcher's handwriting in the field notebook is careful and small. The elder's words are set off from the researcher's own, as good ethnographic practice requires, clearly attributed, as directly transcribed as the situation allowed. The sky east of the islands, a particular look to it, the grandfather's instruction passed down. The notebook open to that page, the ink holding the instruction in a form that the fisherman's grandson no longer needs, because the grounds he fishes have changed, but that the water has not outgrown, the water that received the name Mano Umi, when the people who named it found they needed a word for what it was. On the morning of the 22nd of September 1952, the Kayo Maru no 5 was docked at a port on the Japanese coast with its survey equipment loaded and its mission already written into the official record of the Maritime Safety Agency. The vessel had been assigned to document volcanic activity at the Myojinsho Seamount, a submarine formation south of the Izu Islands that had been producing visible surface eruptions throughout that year. Other ships had already logged the disturbance, discolored water, rising steam, debris and ash breaking the surface in columns visible from a considerable distance. The Kayomaru No. 5 was to go closer. 31 people were aboard when it departed. What made this departure unusual was not that the destination was unknown. It was that the destination's danger was in a meaningful sense already observable. Contemporary ship's logs from vessels that had passed near Myojinsho in the weeks before September described the sea around the seamount as churned by underwater explosions, the surface discolored in wide patches of pale brown and gray where superheated water was venting upward from below. The agency's own records from this period document that the eruption sequence at Myojinsho had been active since the spring of that year, and that surface signs of the activity had been visible to passing traffic across several months. The Kayo Maru No. 5 was not sailing into the unknown. It was sailing towards something that could be seen. The vessel did not return. No distress signal was received. No wreckage of a kind that could reconstruct the final events was recovered. What survives in the official record is the mission log from before departure, the reported state of Myojinsho at the time, and the absence of any further entry. The investigation that followed was conducted by the Maritime Safety Agency and concluded that the most probable cause was the seamount itself, a sudden eruption, an underwater explosion, or some rapid change in the local sea state produced by volcanic activity of a kind that the survey equipment and vessel design of 1952 could not have survived in close proximity. 31 people, one agency finding, and no further record after the morning of the 22nd. Volcanologists who have reviewed the Kayomaru No. 5 case in subsequent decades have described it as a foreseeable tragedy in the specific sense that the conditions at Myojinsho at the time of departure were already demonstrably dangerous, and that the technology and protocols available to a government survey vessel in 1952 were not adequate for close approach documentation of an active submarine eruption. That framing is not a criticism of the crew or the agency. It is an acknowledgement that the case, as hard as its outcome is, holds within the documented record an explanation that requires no departure from the known physical behavior of submarine volcanoes. The seamount did what active seamounts do. The vessel was close enough to be inside the consequence. The Myojinsho eruption sequence of 1952 was itself documented by other vessels and by Japanese scientific observers working at a safer distance, and those observations survive. What they recorded was a seamount undergoing what geologists describe as a series of Surtsean-style eruptions, violent interactions between seawater and rising magma, producing rapid and unpredictable explosive events at the sea surface, with the zone immediately above the active vent site effectively intermittently uninhabitable for surface vessels. The water discoloration documented in those observers' logs is consistent with superheated and chemically altered seawater being driven upward from the volcanic vent. The debris columns visible in those same accounts are consistent with tephra and larger fragments being ejected above the waterline. All of this is documented, all of it is physical, and all of it was already in progress when the Kaio Maru No. 5 departed. The decade following World War II produced an elevated number of vessel disappearances in the waters south and southeast of Honshu, and the Maritime Safety Agency's records from this period reflect that accumulation. Fishing vessels predominantly, small craft working the southern grounds, some without radio equipment, some without weather instruments adequate to the conditions of the Western Pacific Typhoon Corridor. The agency's investigators, working through those files in the early and middle years of the 1950s, found themselves facing a pattern that was alarming in scale, but case by case not particularly difficult to account for. The explanations that emerged from those individual file reviews were consistent and, when taken together, pointed not toward anything anomalous, but toward a specific and identifiable set of material circumstances. The post-war fishing fleet, operating out of Japanese coastal ports, was working under conditions that compounded risk in several directions at once. Overcrowding on established fishing grounds meant vessels pushing farther south into water, where typhoon exposure was greater and sea states less predictable. Fuel shortages in the immediate post-war period meant that vessels sometimes departed without adequate reserves for weather avoidance, committing to a course and unable to alter it if conditions changed. Weather forecasting infrastructure available to small fishing operators in the early 1950s was not what it would later become. Typhoon track data existed, but its dissemination to individual vessel operators working small craft out of smaller ports was inconsistent, and warning time was often insufficient. Radio equipment, where it existed at all on the smallest vessels, was sometimes unreliable. A vessel that went silent in a typhoon corridor in cold seasons, without radio, without adequate fuel reserves, in waters where sea states could change within hours, that vessel's absence from port was not, in the formal investigative sense, mysterious. The Maritime Safety Agency investigators who compiled the loss records from this period noted all of this in their official documentation. Their findings, preserved in the agency's archive, describe the elevated post-war loss rate in terms that are careful and specific, identifying the contributing factors not as evidence of an anomalous zone, but as evidence of an industry operating under post-war material constraints that had not yet fully recovered. Overcrowding, equipment deficits, forecasting gaps. The Western Pacific Typhoon Corridor doing what the Western Pacific Typhoon Corridor does across every decade of recorded observation. These were the findings. They were bureaucratically stated and carefully supported, and they pointed consistently toward the material and the ordinary. There is something in those files, across all the names and dates and last known positions, that resists easy summary. Each entry in the record was a vessel and a crew, a departure logged, a destination noted, and then a silence that became first a delayed arrival, and then an investigation, and then a finding, and then a closed file. The finding, in most cases, was weather or equipment or inadequacy of resources. The finding was sufficient. It did not make the entry smaller. It did not make the absence less real. It simply meant that the sea had done what the sea in that zone, in those conditions, with those vessels and that equipment, could predictably do, and that the agency's record had caught up to it afterward with the language of administrative conclusions. The wartime period introduced its own layer of complexity into the Dragon's Triangle record, though the complexity runs in an almost opposite direction from what popular accounts later suggested. The Imperial Japanese Navy lost substantial numbers of vessels in the Western Pacific during the conflict, including destroyers, submarines, and transport and supply ships in the waters broadly corresponding to the Dragon's Triangle zone. Most of these losses were documented in the context of known Allied operations, tracked engagements, recorded submarine attacks, aerial operations, whose targets and outcomes were logged on both sides. The Allied record, the American Naval Archive in particular, is extensive and specific. What happened to many of these vessels is not unknown. It is documented across multiple national archives in considerable detail. The problem is not with the losses themselves. The problem emerged in the period after the war, when the Japanese Naval Archive, already incomplete due to deliberate destruction of documents in the final weeks of the conflict, and to the physical losses of the war itself, proved to contain gaps around certain engagements and certain vessel losses. Those gaps were genuine. They were also, in the formal historical sense, attributable to the documented chaos of a collapsing military administration destroying its own records, and to the physical destruction of the war rather than to any anomaly in the zone. A vessel lost in a documented engagement, recorded in the Allied archive as a confirmed kill, but whose loss appears as an unexplained gap in the surviving Japanese archive, is not a mysterious disappearance. It is a documentation asymmetry. Popular accounts produced in later decades exploited that asymmetry by incorporating some wartime combat losses into tallies of vessels that had disappeared without explanation in the Dragon's Triangle zone. The mechanism was, in retrospect, relatively simple. A vessel whose loss appeared in the Japanese archive as an unexplained gap could be presented as having vanished without cause in dangerous waters if the Allied records that documented its actual fate were not consulted or not cited. The result was an inflation of the apparent mystery, achieved not by fabricating incidents, but by presenting them through a partial archive that excluded the explanatory records. This is documented by historians of Japanese maritime history who have worked across both the Japanese and Allied archival records from the wartime period. The post-war commercial shipping record adds another layer to the zone's documented history, and it is a layer that is, on examination, more ordinary than the popular account suggested. Reports filed with the Japanese Coast Guard and Maritime Safety Agency in the post-war decades included cases of vessels arriving significantly off course, ships logging sudden compass deviations, and occasional freighters failing to reach scheduled ports. These reports existed. They were filed, investigated, and in most cases resolved. The resolutions documented in those investigations are, across the available archive, broadly consistent. Human error in navigation, equipment malfunction of a kind consistent with the age and maintenance state of the instruments, and severe weather events that pushed vessels off planned courses, or simply ended voyages that had been planned on the assumption of conditions that did not hold. Compass deviations reported by vessels in the zone were investigated, and in the cases where the physical circumstances could be reconstructed, investigators found that the deviations were consistent with proximity to the volcanic and basaltic seafloor formations along the Izu Arc, which produce measurable local magnetic intensity variations that can deflect a compass needle by several degrees. This is a real physical phenomenon. It is also one that is not unique to the Dragon's Triangle, that is well within the range of what careful navigation in a zone of known magnetic variability can account for, and that falls considerably short of the dramatic navigation failures described in the more expansive, popular treatments of the zone's mysteries. The compass moved. It moved by a measurable and explainable amount. The deviation was real. Its cause was identifiable. Freighters that failed to arrive at scheduled ports and later turned up in investigations involving weather routing errors, engine failures, or navigational misjudgments in conditions of poor visibility are represented in the Maritime Safety Agency archive as resolved cases. Not all of them are resolved. Some entries remain as open files where investigation did not produce a finding. Those open files exist. They are across the span of the archive, a small proportion of the total case volume. Their existence does not require an anomalous explanation. Maritime loss across all ocean zones produces unresolved cases, vessels and crews that go without trace and without recovery of evidence sufficient to reconstruct what happened. The Western Pacific, with its typhoon corridor and its complex sea states and its volcanic seafloor, produces those cases at a rate that is, in comparison with similarly exposed ocean zones, not exceptional. The official Japanese government investigation conducted in the early 1950s by the Maritime Safety Agency was undertaken in direct response to public concern following the Kaiomaru No. 5 disaster and the elevated loss rate in the post-war fishing fleet. It was a formal investigation, documented in official records that remain archived and available. Its scope covered the zone's documented loss history, the sea conditions of the Western Pacific, the geological character of the seafloor beneath the zone, and the material circumstances of the post-war fishing industry. Its methodology was administrative and empirical, gathering loss reports, reviewing investigation findings, consulting geological and meteorological data, and producing a formal conclusion about the dominant explanatory factors for the elevated loss rate in the zone. The investigation's conclusions were specific. The dominant explanations for vessel losses in the Dragon's Triangle zone, in the agency's formal finding, were geological and meteorological. Submarine volcanic activity around Myojin Shoal and along the Izubonin Arc was identified as a genuine and foreseeable hazard for vessels operating in proximity to active seamount sites. Typhoon exposure was identified as the primary meteorological factor, with the zone's position in the Western Pacific Typhoon Corridor making typhoon-associated losses statistically predictable. The unpredictable sea conditions associated with the Kuroshio Current, its strong flow, its thermal boundaries, its interaction with opposing winds and countercurrents, were identified as a contributing factor in sea state-related losses. These were the findings. They were written into an official document in the measured language of administrative review, and they pointed steadily and consistently toward the physical world. That document exists. It has been reviewed by historians of Japanese maritime history, and their accounts of what it actually contains are consistent with one another and with the agency's stated findings. The investigation looked at the zone's loss record carefully and at length, and what it found was sufficient to account for what had been documented without requiring any departure from the known behavior of oceans, geology, and weather. The volcanic arc was active. The typhoon corridor was real. The Kuroshio was powerful and variable. The post-war fleet was underfunded, underprepared, and operating in one of the most geologically and meteorologically demanding stretches of ocean on the planet. These things were true simultaneously, and their combination produced losses that were, in the formal finding, explicable. It is worth sitting with the Kayo Maru number 5 a moment longer because the case is in some ways the clearest expression of what the zone's documented record actually shows. The vessel's departure was logged. Its mission was documented. The condition of its destination was already known. Myojin Sho had been erupting visibly for months. The crew of 31 was made up of scientists and agency personnel, whose purpose was to observe and document a geological event of genuine scientific importance. That purpose was real and valuable. The risk was also real, and it was not concealed from anyone involved. The agency sent a survey vessel to document an active submarine eruption in 1952 using the instruments and protocols available to a 1952 government survey mission. The seamount destroyed it. What makes this case sit differently from those cases where the explanation is weather or navigation or equipment is that the explanation here is the seamount doing something that seamounts actively do. There is no gap in the record that requires filling with a hypothetical. The Myojin Sho eruption sequence of 1952 is documented in the logs of vessels that observed it from a safer distance. The behavior of submarine volcanoes in Surtzion eruption is understood well enough that the kinds of event capable of destroying a surface vessel in close proximity are identifiable and have been described in the scientific literature with some specificity. The meeting of that vessel with that seamount at that stage of that eruption was in the formal sense an encounter with a known physical phenomenon, extreme, certainly, lethal, demonstrably, but not anomalous. The post-war fishing vessel losses, taken individually and in aggregate, inhabit a different part of the record, where the Kayo Maru number 9. 5 case has a named destination, a documented hazard, and an investigation finding that connects them directly. The individual fishing vessel entries are often records of departure, followed by absence, a vessel name, a port of origin, a fishing ground destination, or a direction, or simply a departure date, and nothing after it. The investigations that followed these disappearances were working with the available evidence, and in many cases the available evidence was sparse. No radio contact, no witnesses to the final hours, no wreckage recovered from a sea that moves constantly and carries debris across considerable distances before depositing it anywhere that can be connected to a specific vessel. The investigator assigned to each of these files was working from a last known position and a silence. The findings that emerged from those files, weather, equipment, the typhoon corridor, the Kuroshio, are honest findings in the sense that they reflect what the evidence supported and what the zone's documented physical character made probable. They are also incomplete in the specific sense that no finding in a file where the evidence is a departure and a silence can be called fully complete. The maritime investigation closes the file when it has assembled the best available account of what most probably occurred. The file's closure is an administrative act, not an epistemological one. The question of what exactly happened to each of those vessels in each of those final hours is a question that in most cases the record cannot fully answer. What the record can say is what the zone is and what the zone does, and what the zone is, physically, is sufficient to account for a great deal of loss without any remainder. There is a particular quality to reading through maritime loss records from this period. The administrative language of the agency findings, columns of dates, vessel names, last known positions, investigation conclusions, carries within it a kind of patient weight. Each entry is precise in the way official documents are precise, specific about what is known, careful about what is inferred, silent about what cannot be determined. The investigators who produced those files were not, by the nature of their work, the kind of people who left speculation in official records. They noted what the evidence supported, and they stated their findings, and they moved on to the next file. The files stack up, the conclusions accumulate, and what they accumulate into, across the full span of the archive, is a picture of a zone that is genuinely difficult, geologically, meteorologically, hydrodynamically, and genuinely dangerous in ways that require no embellishment. A small post-war fishing vessel heading south from the Izu coast on a clear morning would have had, depending on its equipment and the season, some warning of what the day might bring, and some not. On a clear morning, the sea to the south looks exactly like the sea. The Kuroshio is not visible as a current from a small vessel moving with it. It is felt in the rate of progress, perhaps, or in the slight change of watercolor at its boundaries, or in the quality of the chop where it meets an opposing wind. A developing weather system far to the south and east, still organizing into something that would later cross this zone at force, is not visible from the deck of a small craft heading out to the fishing grounds. The vessel logs its departure at the port. The destination is noted. The morning is clear. The Maritime Safety Agency's archive holds the record of many such mornings. It holds them in the form of departure logs and investigation files, and in some cases closed files with no finding more specific than the general finding that the zone's conditions and the vessel's equipment and circumstances are together sufficient to account for the absence. The archive does not hold what those mornings actually felt like on the water, or what the crews of those vessels understood about where they were going and what might meet them there. That knowledge is gone with the vessels. What survives is the official record, which is careful and specific about what it knows and genuinely quiet about what it does not. The image that the official investigation leaves is not a mysterious one, it is a specific one, a geological and meteorological zone of genuine complexity, documented with care by an agency whose task was to understand what had happened to the vessels in its care, producing findings that pointed steadily toward the physical world and stopped where the physical evidence stopped. The zone had active submarine volcanoes. It had a typhoon corridor that crossed it more than a dozen times in an average year. It had a major western boundary current, whose interactions with opposing winds and sea states produced sea conditions that could change faster than a small vessel without radio could respond to. It had a seismically active trench running along its eastern edge, producing earthquakes capable of generating sudden and significant changes in local conditions. The agency's investigation looked at all of this and concluded that it was sufficient. It was. The formal document that contains those conclusions sits in an archive. It is written in the administrative Japanese of a post-war government agency, careful, specific, measured in its claims, precise in its citations to the meteorological and geological record. It does not use the phrase dragon's triangle. It does not reach for drama. It describes a zone of the Western Pacific with specific physical characteristics that produce specific categories of maritime hazard, and it traces the documented vessel losses of the post-war period through those categories until each loss has been accounted for to the degree the evidence allows. Where the evidence does not allow a specific finding, the document says so. It does not fill the gap with inference. It records the gap as a gap and moves on to the next case. That quality of restraint, the willingness to say what is known and to stop at the boundary of what is known, is the quality that distinguishes the official investigation record from many of the popular accounts that were later written about the same zone and the same waters. The official record drew its line at the knowable. The knowable across the full archive was sufficient to account for what had been documented. The volcanic arc explained the Kaiomaru number 5. The typhoon corridor and the post-war material conditions explained the elevated fishing vessel loss rate. The archival asymmetry between Japanese and Allied records explains some part of what had appeared in partial accounts to be unexplained wartime losses. The physics of the Kuroshio current, the seismicity of the Izubonin arc, and the documented behavior of navigation instruments near magnetized seafloor formations explain the compass deviations and the difficult sea states reported by vessels that made it back to port and filed their accounts. Across all of this, the investigation's formal findings remained consistent. Geology, meteorology, the Western Pacific doing what the Western Pacific does in one of its most geologically and meteorologically complex regions. These were not small explanations. They were not dismissive ones. The volcanic arc that destroyed the Kaiomaru number 5 is a tectonic boundary where two of the Earth's great plates converge, sustaining volcanic activity across thousands of kilometers of seafloor. The typhoon corridor that the zone sits inside is one of the most active storm-generating systems on the planet's surface, tracked and documented by the Japan Meteorological Agency across decades of continuous observation. The Kuroshio current, moving through the zone's western boundary, carries more water per second than all the rivers on Earth combined. These are not modest physical facts. The investigation that cited them as sufficient explanations for the zone's documented loss record was not minimizing what had happened. It was placing it inside the full scale of what the zone actually is. The document that records those conclusions is still in the archive. It has been there since the 1950s, accumulating the quiet patience of all documents that are written once, accurately, and then stored while the world continues to produce accounts of the subject they describe. The investigators who wrote it are long gone. The vessels they were investigating are gone. The crews of those vessels are gone. The document remains in its archive with its columns of findings and its measured conclusions and its careful administrative silence at the boundary of what could be determined. It is a record of what the official investigation found when it looked at the zone's history with the best available evidence and the formal tools of a government inquiry. What it found was the physical world in its full and sufficient complexity, accounting for what had been lost. The line it drew was at the knowable, and the knowable, across all the files and all the findings and all the careful language of that official record, turned out to be quite enough. In 1989, a book arrived on shelves. Its cover was printed in deep blues and blacks, the title set in letters that suggested antiquity without committing to a specific era, and its author's name sat below it with the authority of someone who had been here before, who had, in fact, built a very similar structure once already in the Atlantic. Charles Berlitz called it the Dragon's Triangle, and in a bookshop in that year, before the internet had made the distance between a footnote and its source a matter of seconds, the book had the particular weight of a revelation. It sat among companions, other volumes with similar covers, similar spines, similar promises, and it offered a specific thing, a name for a zone of the Pacific that had been called many things by many people over many centuries, now arranged into a single coherent claim that a reader could carry home and open in a quiet room. The book positioned itself plainly as a companion to something already famous. The Bermuda Triangle had been a publishing phenomenon since the early 1970s, a zone of the Atlantic that had accumulated, through a series of books and articles, a reputation for swallowing ships and aircraft in numbers and under circumstances that defied ordinary explanation. Berlitz had been instrumental in building that reputation. His 1974 book on the Bermuda Triangle had sold in enormous numbers, had been translated into many languages, had established a template, a geographic zone, a history of disappearances, a suggestion of something science could not account for, that proved enormously durable as a publishing form. The Dragon's Triangle applied that template to the Pacific. Here was the eastern counterpart, the book argued. Here was another zone, another set of losses, another accumulation of incidents that pointed towards something unexplained and possibly inexplicable. A reader picking it up in 1989 would have encountered a broad and confident claim. Berlitz argued that the zone had swallowed hundreds of ships and aircraft across the centuries. He argued that Japan had formally declared it a danger zone. He argued that the disappearance rate in the Devil's Sea exceeded even that of its Atlantic counterpart. He framed the zone as an area where magnetic anomalies operated at unusual intensity, where navigation equipment failed with a frequency that went beyond the statistical, where the losses had a pattern that geology and meteorology could not by themselves account for, and woven through the scientific framing were older threads, references to the lost Pacific civilization of Mu, to connections between the Dragon's Triangle and Atlantis, to the possibility that both zones shared a property that pointed not toward the natural, but toward something else entirely. The book was not shy about where that line of reasoning led. What a reader in 1989 would not easily have been able to do was trace the claims back to their sources. The primary records Berlitz cited, Japanese government documents, Maritime Safety Agency reports, historical naval logs, academic surveys, were not available in translation in most bookshops, not cataloged in most public libraries, not reachable within the span of an evening. The footnotes pointed toward things. Whether those things contained what the footnotes said they contained was a different question, and it was not a question that an ordinary reader in 1989 had any practical means of answering. The claim and the citation sat together on the page, and the citation performed its function. It suggested a paper trail, a foundation, a structure of evidence beneath the argument. Whether that structure bore the weight it was asked to carry was not immediately apparent. A decade and a half before The Dragon's Triangle was published, a researcher named Larry Kusha had done exactly that kind of checking, had sat down with the primary records and traced Berlitz's Bermuda Triangle claims back to their supposed sources with careful and patient attention. His 1975 book, The Bermuda Triangle Mysteries Solved, had gone through the incidents Berlitz cited one by one. The process had produced some consistent findings. Incidents Berlitz described as mysterious had documented explanations that Berlitz had not mentioned. Storms that had been recorded in weather logs and contemporary newspaper accounts as severe were described in Berlitz's account as calm, rendering the losses more puzzling than the primary record showed them to be. Some incidents had occurred outside the zone's own boundaries. Some had happened in conditions, heavy weather, night, mechanical failure, that were documented but not acknowledged. And in several instances, the sources cited could not be found, or did not contain the information attributed to them, or did not exist in the form the citation implied. Kusha's methodology was not complex. He found the original incident reports. He found the contemporary newspaper accounts. He found the weather records. He found the investigation files. He placed what those documents said alongside what Berlitz had written about them. The gap between the two was in many cases substantial. That gap was what the Bermuda Triangle mystery solved, documented, not the non-existence of vessel losses in the Atlantic, which were real and verifiable, but the difference between those losses as the primary record described them and those losses as Berlitz had chosen to present them. Couchet and other critics who examined the Dragon's Triangle found a similar pattern in the Pacific volume. The claim that Japan had formally designated the zone a danger zone, a specific verifiable governmental act, could not be substantiated in the primary administrative record. The figures Berlitz cited for vessels and aircraft lost in the zone were drawn from sources that, when traced, either did not support the figures given or could not be located in the form cited. The Japanese government's own investigation from the early 1950s, conducted by the Maritime Safety Agency in response to genuine public concern following the loss of a survey vessel, had concluded that geological and meteorological factors were sufficient explanations for the documented losses in the zone. The investigation had pointed to submarine volcanic activity, to typhoon exposure, to the unpredictable conditions associated with the Kuroshio Current. It had not concluded that the zone presented anomalies that lay outside the range of the knowable. Berlitz's treatment of those findings, as independent researchers subsequently noted, did not accurately represent what the investigation had found. The treatment of World War II losses was a particular point of concern for historians of Japanese maritime history. The Pacific War had produced enormous destruction across the Western Pacific. Destroyers, submarines, transport ships, cargo vessels lost in documented combat operations, in recorded engagements, under Allied action that was itself meticulously catalogued in the archives of multiple nations. Wartime destruction of Japanese naval records had left some of these losses imprecisely documented on the Japanese side, creating gaps in the record that were real and acknowledged by historians. But those gaps were not the same as mystery. A ship lost in a documented engagement in a particular stretch of water was not an unexplained disappearance. Incorporating those losses into a tally of mysterious peacetime vanishings, treating the archival gap as a narrative opening, was a methodological choice that historians of the period found difficult to defend. The losses were real. The explanation for most of them was not absent. It was simply located in a different archive, under a different government's records, in a set of documents that had survived the war intact. The treatment of source material from Japanese maritime traditions followed a similar pattern. The cultural history of Mono-umi, the Sea of Misfortune, the Sea of the In-Between, was genuine. Coastal fishing communities along the Izu Peninsula and the Ogasawara Islands had maintained inherited warnings about particular grounds and particular seasons for generations, and ethnographic researchers had documented those traditions with care in the 20th century. The Ryukyu Kingdom's trade records documented vessel losses on routes through the Western Pacific that had not been satisfactorily explained. Chinese maritime records from the period of the Great Ming voyages describe difficult and changeable waters in the Western Pacific. This was all real material, genuinely part of the record, but Berlitz's treatment of it, as scholars of Japanese maritime history noted, moved from acknowledgement of genuine cultural tradition into assertions that those traditions confirmed the existence of anomalous phenomena operating at a scientific level, a leap the source material did not support, and which the primary documents, read in their own terms, did not make. The comparison to the Bermuda Triangle brought its own complications. By 1989, the Bermuda Triangle's reputation among researchers and oceanographers was considerably different from its reputation in popular culture. The United States Coast Guard had issued formal statements noting that the loss rate in the Bermuda Triangle zone was not statistically elevated compared to other heavily trafficked areas of similar size and similar weather exposure. Lloyd's of London, whose marine insurance assessments are among the most practically grounded evaluations of maritime risk in the world, did not rate the Bermuda Triangle Zone as requiring special insurance consideration. The scientific discrediting of the Bermuda Triangle as a genuine anomaly was by 1989 fairly well established in the research literature, even if it had not fully penetrated popular awareness. By explicitly framing the Dragon's Triangle as the Bermuda Triangle's Pacific counterpart, sharing its properties, its pattern, its explanatory puzzle, Berlitz imported the Bermuda Triangle's existing scientific status directly into Dragon's Triangle discourse. The two zones were linked not only by the comparative argument, but by the criticism that comparison invited. If the Atlantic Zone had been shown to lack the anomalous loss pattern that made it famous, the comparison raised the same question about the Pacific Zone. The framework of Mu added another layer, the lost Pacific civilization, a continent said by some writers to have once occupied the Central Pacific and to have vanished beneath the ocean in a prehistoric catastrophe, was a theory with a specific origin. It had been proposed in the late 19th century, elaborated by various writers in the early 20th, and had not fared well against the development of plate tectonic theory, which described the Pacific seafloor's actual geological history in terms that left no room for a sunken continent of the required scale. Berlitz's invocation of Mu as a possible explanatory framework, the Dragon's Triangle as the site of Mu's remains, the anomalous properties of the zone as somehow connected to an ancient civilizational catastrophe, drew on a tradition that the geological sciences had examined and found without evidential support. It is the kind of framework that a reader in 1989, without easy access to the geological literature, might not immediately have been equipped to assess. The claims sat alongside the other claims on the page, and the page looked similar from a distance. And where the book was translated into multiple languages, it appeared in bookshops across Europe, North America, and Asia. It established the term Dragon's Triangle as the dominant English language name for the zone in a way that no previous publication had managed. Before Berlitz, the Devil's Sea had a reputation in Japanese maritime culture, and among the small community of researchers interested in the region, but it did not have an internationally circulating name that a reader in London or Toronto or Sydney could pick up and immediately attach to a genre of mystery. After Berlitz, it did. The term Dragon's Triangle became the index under which the zone's reputation was organized in popular culture, and the book that established it shaped what that reputation contained, which incidents were emphasized, which explanations were considered, which framework was offered for understanding what the zone was and why it had the character it did. That shape persisted. The book and the framework it established moved into other books, into documentary films, into magazine articles, into the early internet, where information about the zone accumulated in the 1990s and circulated without always carrying the context that would have allowed a reader to evaluate it. A claim that appears in a published book, cited in good faith by a subsequent article, cited again in a later documentary, accumulates a kind of referential weight that is distinct from evidentiary weight, but can be mistaken for it at a distance. The Dragon's Triangle became a topic about which a great deal had been written, and a great deal of what had been written drew on the same original framework, which drew on the same original claims, which pointed back toward sources that the primary record did not always support. Independent researchers who worked in the Japanese maritime archives and read the relevant source material in its original form found the zone's actual history both more specific and more interesting than the popular account suggested. The geological record was remarkable and extensively documented. The tectonic setting, the convergence of two major oceanic plates, the sustained volcanic activity of the Azubonin Arc, the extraordinary depth of the Azubonin Trench was genuinely unusual and had been the subject of serious scientific attention for decades. The meteorological record showed a zone that was, by any reasonable measure, one of the most weather-exposed stretches of open ocean on Earth, with typhoon track data spanning generations and earthquake records reaching back through Japanese historical accounts into the cultural record, embedded in Shinto and Buddhist maritime tradition and in the oral histories of coastal fishing communities, was layered and specific and genuinely reflective of accumulated human experience with a difficult and changeable sea. None of this required embellishment. The actual record, read in its own terms, rather than through the frame of a mystery that needed to be sustained, was sufficient, and in some ways more striking for being grounded in what was verifiable, rather than in what could only be asserted. A seamount rising from the abyssal plain and venting superheated water into the cold dark above it, still 1,000 meters from the surface, is an extraordinary thing. A tectonic plate boundary sustaining continuous seismic and volcanic activity across hundreds of kilometers of seafloor is an extraordinary thing. A current pressing northeastward through dark open water with sufficient force to generate sea states that small vessels cannot survive is a genuine and documented hazard that has cost real lives across centuries of Pacific navigation. These are not lesser facts for having explanations. They are, in some ways, more interesting, more durable, more precise, more available to the kind of sustained attention that a mystery dependent on unverifiable sources cannot quite support in the same way. The specific misrepresentation that historians of Japanese maritime history found most troubling was the treatment of the 1950s government investigation. The investigation had been a real and serious undertaking, commissioned in response to genuine public concern, conducted by the Maritime Safety Agency, with the resources available to a post-war Japanese government, still rebuilding its institutional capacity. It had produced findings. Those findings existed in documents that were archived, and for researchers with the appropriate access, readable. The investigation had concluded that the dominant explanations for vessel losses in the zone were geological and meteorological. Submarine volcanic activity around the Myojin-sho seamount, typhoon exposure, the unpredictable conditions of the Kuroshio Current. The investigation had pointed toward the knowable and had found it sufficient. Berlitz's characterization of those findings, as independent researchers subsequently noted after examining what the documents actually said, did not accurately reflect what the primary record contained. The investigation was cited, its conclusions were described, but the description and the document did not match in the ways that mattered. That gap between a cited document and what the document actually said is in some ways the most precise image of what the popular account of the Dragon's Triangle involves. The document exists. It sits in an archive. Its language is careful and administrative and specific. Its conclusions are drawn from investigation rather than from imagination, and they point in a direction that is clear and measured and, on the whole, unsurprising given what the zone's geology and meteorology actually are. A book published in another country, in another language, about events that occurred in a stretch of water that most of its readers would never see, described those conclusions in a form that the conclusions themselves did not contain. The gap between the description and the document is not a dramatic thing. It does not announce itself. It simply exists, quietly, in the space between a footnote and what the footnote points toward. A space that in 1989 was practically inaccessible to most readers, and that has gradually, over the decades since, become more available to anyone willing to look. The book that named the zone did not fabricate the zone's physical reality. The Western Pacific at those coordinates is genuinely complex, genuinely hazardous by the measure of any honest meteorological or geological account, genuinely the site of vessel losses across a long span of human maritime history. What the book arranged, and what critics have carefully documented, is the space between that physical reality and the claims made about it, the incidents that appeared without the context that would have explained them, the sources that pointed toward things they did not quite contain, the losses that belonged to other categories folded into a tally that treated them all as equivalent. The arrangement produced a thing, a name, a reputation, a comparably scaled mystery to set against the Atlantic's own, and that thing had a life in publishing and popular culture that the underlying record, read plainly, would not have sustained in the same form. The Japanese government's investigation findings remain in their archive. They have not been revised. The conclusions the investigation reached, pointing toward geology, toward weather, toward the documented hazards of a genuinely complex stretch of ocean, are the same conclusions they were when they were written, in careful administrative language, by officials working from the evidence available to them in the years following a real disaster that had cost real lives. The document does not know what was written about it. It simply persists in its archive, its columns of findings, unchanged, its language still measured and plain, its account of what the evidence showed sitting quietly in the same form it has always occupied. A reader who traces the popular account back to that document and reads what the document actually says arrives at a gap. The gap is not dramatic. It does not close cleanly or produce a revelation. It is simply a space between two accounts of the same events, one of which was built from the primary record, and one of which was built from something else, from other accounts, from frameworks imported from other zones, from a publishing moment that had an appetite for a particular kind of story, and a zone of the Pacific that had in its cultural and maritime history enough genuine material to make the structure plausible at a distance. The document persists. The water above it continues to move in the way it has always moved. The Kuroshio pressing northeastward, the tectonic plates continuing their slow convergence, the typhoon tracks crossing the zone with the frequency the meteorological record shows they always have. The gap between the popular account and the primary record remains open, not because the record is obscure or inaccessible, but because the popular account established itself early and circulated widely and became, for many readers, the available version. What the document says and what was written about it, those two things sit in the same world without quite touching. The archive holding its careful language, the question of the distance between them still available to anyone who chooses to measure it. Somewhere on the floor of the Western Pacific, beneath several thousand meters of still and pressurized water, there are pale crystalline structures embedded in the dark sediment. They are not large. Some are no bigger than a stone. Others have grown to the size of a car or a small boat, pressing up through the mud in irregular formations that a passing camera sled would illuminate briefly before moving on into the dark. They are methane hydrate deposits, frozen gas held in a lattice of water molecules, compressed into solidity by the weight of everything above them. The temperature down there is just above freezing. The pressure is immense. Under those conditions, the gas does not escape. It remains in place, crystalline and pale, patient in a way that only geological things can be patient, waiting for the conditions that made it stable to remain as they are. The zone they occupy has been crossed by wooden hulls and steel hulls and fiberglass hulls for centuries. The people crossing it have not known the deposits were there. There is no reason they would. The seafloor at that depth is not a place that surface knowledge reaches. A vessel passing over a methane hydrate field leaves no impression on the field, and the field in turn leaves no impression on the vessel unless the conditions that hold it in place change, and then the chemistry of it changes with them, and what was frozen becomes a rising column of gas moving upward through the water column toward a surface that does not know it is coming. This is one of the things the Western Pacific seafloor actually does. Not as legend, not as metaphor, as documented geophysical process, recorded in the literature of ocean chemistry and seabed geology, present in the physical record of a region that has accumulated more names for its danger than almost any comparable stretch of ocean on Earth. The real processes beneath the Dragon's Triangle Zone are not simple. They are, if anything, more layered and more strange than the stories that have been written around them. They require no embellishment. They are worth sitting with exactly as they are. The methane hydrate deposits along the regional seafloor formed over long periods from organic material settling into the sediment and decomposing under pressure. Microbes break the organic matter down. The gas produced migrates upward through the sediment and reaches the zone of temperature and pressure where hydrate forms, and there it is held. Scientists studying similar deposits in other parts of the world's oceans have found that seismic disturbance can destabilize them. A significant tremor along a nearby fault can alter the pressure field in the sediment enough to trigger a release. The hydrate dissociates. The gas escapes upward. In sufficient volume, a column of rising gas in disturbed water can reduce the effective density of the water column above the deposit, a reduction that, depending on its scale, has been proposed as a mechanism for affecting the buoyancy of a vessel passing over it. The research on this mechanism is ongoing. The physics of it is not disputed. What remains under investigation is the scale at which it operates and how frequently it reaches the surface in forms that affect anything above the waterline. The Izubonin Arc, running along the eastern boundary of the region, produces hundreds of measurable seismic events per year. Japan's National Research Institute for Earth Science and Disaster Resilience logs them continuously. The record runs back across decades. Magnitude notations and timestamps accumulated in long columns, each entry a moment when the seafloor moved along one of the most active tectonic boundaries in the world's oceans. Most of these events are minor. The instruments detect them where no surface observer would. The water above them shows nothing, but the larger events, those exceeding magnitude 6, 0, or 7, 0, which the arc produces with documented regularity, generate seafloor displacements that propagate upward through the water column in forms that have been recorded in historical Japanese accounts for as long as those accounts have existed. Earthquake-associated sea disturbances, sudden changes in current pattern, localized surges over shallow ground. The record of these events stretches back through centuries of coastal Japanese observation, through the shipping records of the Ryukyu Kingdom, through the logs of vessels that crossed the Western Pacific in every era and noted what the sea did around them without having language for the mechanism that produced it. A seismograph read out from a moderate Izubonin arc event looks on paper like a brief agitation in what was otherwise a straight line. The needle trace moves, the peak is noted, the magnitude is assigned, the timestamp is recorded. Then the trace settles again, and the instrument returns to monitoring the next moment, and the next, because the arc does not stop producing events just because one has been recorded. The file in which that readout is stored is one of hundreds from the same stretch of seafloor in the same year. Each one represents a real moment when the ground beneath the Western Pacific moved. Each one left its mark in the dataset and was logged and was filed, and the water above it continued on toward whatever it was doing, as water does. The rogue wave is a different kind of event. It does not come from below. It emerges from the surface conditions themselves, from the specific meeting of forces that the Western Pacific Zone near Japan sustains with unusual frequency and intensity. The Kuroshio current moves northeastward at speeds that can reach 5 or 6 knots in strong seasonal conditions, pressing warm water against cooler surrounding seas and generating thermal gradients that affect wind patterns and wave behavior above it. When that current runs against opposing winds or against countercurrents driven by distant storm systems, or against the long swells generated by typhoons hundreds of miles away, the wave interactions that result are nonlinear. The mathematics of wave superposition in these conditions allows for individual wave structures that are dramatically larger than the surrounding sea state. Waves that arise not from a single storm, but from the precise geometric alignment of multiple wave trains arriving at the same point at the same moment. Modern satellite altimetry has confirmed that these structures are real and that they occur with measurable frequency in strong current systems. Wave buoy instruments in the Western Pacific have recorded them. A buoy dataset entry for a rogue wave event looks unremarkable at first. Rows of measurements, the recorded sea state, the average wave height, and then there is one number that does not match the others. A single vertical spike in the record, a height that sits in the dataset as a calm and factual entry, surrounded by numbers that do not prepare the reader for it. 20 to 30 meters. That is the range that wave researchers associate with the largest confirmed rogue structures in active current systems. These are waves taller than a 6-story building, arising with little warning from a sea state that may not otherwise be severe, lasting for a matter of seconds before the geometry that produced them dissolves back into the general surface state. A vessel encountering one without warning, and there is, in most cases, very little warning, would have no framework to predict it. It would be logged afterward, if anything could be logged, as an anomalous sea event. Or it would not be logged at all, because the instrument that would have logged it would no longer be above the surface. The zone's typhoon exposure is not, in the scientific literature, a matter of significant controversy. The Japan Meteorological Agency has maintained continuous typhoon track records since 1951, and those records show that the Dragon's Triangle Zone averages more than 12 typhoon track crossings per year. That number is not presented as a maximum, it is the average. Some years produce fewer crossings, some produce more. What drives the frequency is the same thing that drives much of the zone's physical character, the Kuroshio current. Its warmth feeds developing storm systems. Sea surface temperatures maintained by the current provide the energy that allows tropical cyclones to intensify with unusual speed as they cross the zone, a process the meteorological literature describes as rapid intensification, defined as an increase in sustained wind speed of at least 35 miles per hour within 24 hours. Storms that enter the zone as tropical depressions can emerge from it as major typhoons. Vessels that depart port in a reasonable sea state can find themselves inside rapidly intensifying systems within hours, the barometric pressure dropping fast, the wind and wave conditions escalating in ways that outpace the forecasting technology of any given era. The Meteorological Agency's Typhoon Track Archive is a dense document, visualized on a map. The accumulated track lines of 7 decades of storms crossing the Devil's Sea Zone form a pattern of extraordinary density over that particular patch of ocean, line after line, each one a documented path, the colors and symbols differentiating storm category and year, the whole record pressing down on that zone like a kind of geological stratum of weather. Each line in that archive represents a real storm, a real system of wind and water and lowered pressure that cross the same water where the Kuroshio presses northeastward, and the volcanic arc sends its tremors upward through the sea floor, and the hydrate deposits sit pale and still in the sediment below. The file continues to grow each season. Each new typhoon track that crosses the zone is added to the record. The water beneath those tracks continues to move, as it always has, warm and fast, along the Kuroshio's edge, cold and slower, where the current meets surrounding seas, deep and pressurized, along the walls of the Izubonin Trench. Magnetism in the zone is a real phenomenon, documented by Japanese geophysicists whose work has appeared in peer-reviewed journals, including Earth and Planetary Science letters. The seafloor along the Izu Island chain is composed substantially of basaltic and volcanic rock, laid down through successive episodes of submarine volcanic activity over long geological periods. These rocks carry measurable magnetic properties. Where they are concentrated in particular formations, they produce local variations in the magnetic field that surface compass instruments can detect. The research records compass deflections of several degrees in certain areas, real deviations from the expected field, tied to the distribution of magnetized material on the seafloor below. This is a geophysical fact. It is also neither unique to the Dragon's Triangle nor of a magnitude that would, on its own, account for catastrophic navigation failure. The anomaly maps produced by Japanese geophysicists are precise documents, contour lines drawn across the survey area, each line marking a deflection value, the data patient and specific on the page. Reading them, what one finds is a region of measurable magnetic complexity, not a zone of chaotic instrument failure. The deflections are there. They are real. They are also measured in degrees, not in wholesale compass reversals, and they exist within a system of geophysical variation that covers much of the western Pacific Basin. A magnetic anomaly survey chart is not a dramatic object. It is a technical document, printed in the standard style of geophysical publications, with a legend and a scale bar and contour intervals selected to make the variations visible. The contour lines bend and loop across the survey area, following the distribution of magnetized rock below. Some areas show stronger anomalies. Others show deflections close to the regional average. The chart covers the Izu Island chain in the careful, specific language of quantitative geophysics, and what it shows is a seafloor whose magnetic character is variable and complex, as one would expect from a tectonic setting that has been producing and repositioning volcanic material for millions of years. Compass instruments passing over that seafloor register what they register. The data is there. The data is, in the end, the most honest account the zone has produced of what it actually does to instruments that attempt to measure it. What the ocean does in this zone, taken together, is not a simple thing. The volcanic arc produces continuous seismic activity and occasional catastrophic eruptions. The seafloor holds gas deposits that respond to pressure changes. The current generates thermal gradients, sharp wave boundaries, and conditions that favor the formation of extreme individual waves. The typhoon track density exceeds that of almost any other maritime zone on Earth. The magnetic field varies measurably with the distribution of volcanic rock below. None of these phenomena require one another to be significant, and yet all of them occupy the same zone of ocean, the same bounded region of the Western Pacific that has been crossed by sailors across centuries, named and renamed by cultures that understood, without the technical vocabulary, that something about this water was different. The names they gave it, Mano Umi, the Devil's Sea, the Dragon's Triangle, were not precise geophysical descriptions. They were the accumulation of experience, the slow sediment of what generations of people had learned about a particular stretch of water by crossing it, and sometimes by not returning from it. It is worth spending a moment on what the Izubonin volcanic arc looks like from a geophysical perspective, because the perspective is one that does not often reach the general record. The arc stretches roughly from the Izu Peninsula south toward the Mariana Islands, a chain of volcanic structures, both above and below the waterline, islands with their sharp profiles, seamounts rising from the abyssal plain toward depths that a keel will never reach, submarine calderas where magma chambers have collapsed into the sea floor, leaving wide circular depressions on the ocean floor. Along the arc's length, hydrothermal venting occurs at numerous sites, releasing superheated water into the cold, deep ocean in thin columns visible to submersible cameras as shimmering distortions in the already dark water. The venting carries minerals up from depth and deposits them in chimneys of sulfur and iron compounds that build slowly over geological time. The chemistry of the water around these vents is different from the surrounding ocean. Acidic, mineral-rich, warm, inhabited by organisms that have adapted to conditions that would be lethal to most surface life. The Meiji Sho seamount sits along this arc. In 1952, it was an active eruption, producing surface expressions that passing vessels had documented in their logs. Water discolored by volcanic material, steam rising from the sea surface, debris visible from a distance, the sea around the eruption disturbed by underwater explosions. The Maritime Safety Agency surveyed the seamount surface activity afterward. The waters around it have continued to show occasional signs of activity in subsequent decades. The seamount is not extinct. It is a structure on an active arc, and what the arc does along its full length, is a continuous process, geological in its timescale, indifferent to the passing of surface vessels above it. The Sea Surface Temperature Archive for the Western Pacific, maintained by Japan's Meteorological Agency and supplemented by international oceanographic records, shows a zone of consistently elevated surface temperatures along the Kuroshio's path through the Dragon's Triangle region. The current carries water northward from subtropical latitudes, and that water holds warmth longer than the surrounding ocean because it is deep, fast, and relatively isolated from the cooler offshore waters it runs beside. The thermal boundary where Kuroshio water meets surrounding seas is not a gradual transition. It is a sharp gradient, a line on the surface of the ocean where the temperature drops measurably over a short distance, where the density difference between water masses generates turbulence, where the atmospheric conditions above change as warm oceanic air moves over cooler surrounding air masses. In the right conditions, this boundary produces fog, dense, low fog that moves across the surface in long, slow sheets, reducing visibility to almost nothing, while the sea beneath it remains relatively calm. A vessel in that fog is navigating by instrument in conditions where landmarks and horizon are both gone, the surface flat and gray below a sky it cannot see, the fog drifting across it as though the ocean were breathing. On a clear day in the zone, the Kuroshi's edge is sometimes visible from a ship's deck. The color of the water changes. On one side, the deep blue of the current, warm, saturated, moving fast. On the other, the greener or grayer tones of surrounding cooler water. Slower, its surface texture slightly different, where the wind catches it differently. The boundary between them is not a fixed line. It shifts. The current meanders. It generates eddies that spin off from its edges and drift into surrounding water, carrying warm Kuroshio water into regions that are otherwise cooler. These eddies are visible in sea surface temperature satellite imagery as swirling patterns of color, warm water enclosed in a rotating structure, surrounded by cooler water that is gradually absorbing it. The ocean in this zone is not a stable medium. It is in constant motion, generating structure at scales that range from the microscopic turbulence at the current's boundary to the basin-wide circulation pattern that carries Kuroshio water across the North Pacific toward the Eastern Ocean. The typhoon forms in this water. A tropical depression organizes itself over sea surface temperatures that are warm enough to sustain it, and the Kuroshio provides exactly that warmth across the zone's western extent. Japan's Meteorological Agency satellite imagery has documented the genesis of typhoon systems in this zone across 7 decades. The spiral of cloud organizing over warm water, its rotation tightening as the system draws energy from the sea surface below, the eye forming as the storm reaches typhoon intensity, the whole structure moving on a track that may take it over the zone or northward toward the Japanese home islands or out into the open Pacific. The satellite image of a typhoon forming is not a frightening image. It is a physical process made visible. Warm water, rising air, the Coriolis force turning the developing convection into a curve, the cloud organizing itself, the rotation tightening, the process operating according to thermodynamics and fluid dynamics across a vast scale, entirely indifferent to what it looks like from a vessel below it. 167 typhoons have been documented crossing the Dragon's Triangle zone in the period from 1951 to 2021. That number comes from a careful reading of the Meteorological Agency track archive, counting systems whose documented tracks passed through the zone's approximate boundaries during those 7 decades. It is not a dramatic number in its context. It is an average of roughly 4 systems per year. The average of more than 12 crossings per year in the broader dataset includes weaker tropical systems and extratropical storms that the track archive categorizes differently from named typhoons. What the full record shows is a zone of ocean that sees organized tropical and extratropical storm activity with a frequency that exceeds most of the world's maritime regions. Storms pass over it that are already at full strength. Storms intensify within it rapidly. Vessels crossing it in typhoon season cross it in the knowledge, or in earlier centuries, in the ignorance, that the sky above it can change faster than in almost any other region of ocean. The volcanic arc beneath continues its work through all of this. It does not respond to surface weather. It does not respond to the Kuroshio's warmth or the typhoon's passage or the seasonal changes in fog and current and wave height. It operates on its own timescale, the plates moving against one another at rates measured in centimeters per year. The accumulated stress releasing in events that propagate upward through the water column at the speed of sound in seawater, roughly 1.5 kilometers per second, arriving at the surface as a pressure wave that no human observer at the surface would notice. The seismic record at Japan's monitoring stations captures these events continuously. The instruments receive the signal, the timestamp is noted, the event is logged, the trace on the readout settles again, and the arc continues. There is something in the combination of these things: the current, the typhoons, the volcanic arc, the rogue wave conditions, the hydrate deposits, the magnetic variations, that the scientific literature handles as distinct phenomena, studied in their respective disciplines, with their respective methodologies and publication venues. Oceanography addresses the current, meteorology addresses the typhoons, seismology addresses the arc, geophysics addresses the magnetic anomalies, marine chemistry addresses the hydrate deposits, wave physics addresses the rogue wave conditions. Each discipline produces its own precise and careful account of one layer of what the zone does. What the disciplines have produced, taken together, is a portrait of a region of extraordinary physical complexity, a convergence of geological, oceanographic, and meteorological factors that does not have a precise parallel anywhere else in the world's oceans. The zone is not unique in having any one of these features. Other active arcs exist, other strong currents exist, other high typhoon frequency regions exist. What is relatively uncommon is their concentration in the same bounded region, interacting with one another in ways that are still being understood. The research continues. New deployments of oceanographic buoys along the Kuroshi's path add to the wave height record. New satellite missions improve the spatial resolution of sea surface temperature mapping. New seismograph networks installed on the seafloor along the arc capture events that older surface-based instruments missed. The magnetic survey coverage of the Izu Island chain has expanded as successive Japanese research cruises have extended the survey grid. Each addition to the dataset is a small increment of precision, another measurement, another timestamp, another data point placed in the long record of what this particular stretch of ocean does on any given day and in any given season. The record is patient in the way that scientific archives are patient. It accumulates without urgency. It does not require the phenomena it documents to be dramatic in order to be worth recording. A magnitude 4, 2 seismic event on the Izu Bonin arc is logged with the same care as a magnitude 7. 0, a sea surface temperature measurement from a calm autumn day, is preserved with the same fidelity as one from a typhoon passage. Everything the zone does is in the record, in its actual scale, without inflation. The methane hydrate deposits remain in place on the seafloor. They are not in the process of catastrophic release. The pressure and temperature conditions that hold them stable continue to hold them stable, as they have for the period over which these deposits have been studied. The crystalline structures sit in the sediment, in the dark, under the weight of several thousand meters of water, in the still cold of the deep Pacific floor, where the pressure does not fluctuate, and the temperature does not change, and the sediment accumulates, grain by grain, at a rate that geological time measures easily, and human time can barely register. The Kuroshio continues northeastward. Its speed in the zone varies seasonally, reaching its highest in summer and slowing somewhat in winter, but it does not stop, and its thermal influence on the region's weather does not pause between seasons. The warm water it carries northward continues to fuel storm development and maintain the sea surface temperatures that make the zone one of the most energetically active in the world's oceans. Where the current's edge meets cooler surrounding water, the boundary shifts and meanders and generates its eddies, which spin off and drift and eventually dissipate as the surrounding ocean absorbs their warmth. The current itself is replenished continuously from the south, carrying new warm water northward, replacing what has been mixed into the surrounding ocean, maintaining the thermal structure that makes the zone what it is. The Japan Meteorological Agency's Typhoon Track Archive grows by a few entries most years. A new season of Western Pacific tropical cyclone activity produces its storms, and some of them cross the zone, and their tracks are added to the record. The archive for a given decade, pulled from the database and displayed as a map, shows the accumulated density of track lines over the zone in that period, the lines close together in some years, more spread in others, but consistently concentrated over the warm water of the Kuroshio's path through the Dragon's Triangle region. The file from the current decade sits alongside the files from every preceding decade since 1951. The full record, displayed together, is one of the more striking visual documents in the Meteorological Agency's holdings. The sheer density of storm tracks over that one stretch of ocean, each line representing a real system that crossed real water and encountered real vessels and produced real sea states in the record of the ships that crossed it. The Western Pacific at night is not a quiet place in any meteorological or geological sense. Its surface moves under the influence of the current, the tides, the distant storms that send their swells outward across thousands of miles of open ocean to arrive here as low, long rollers from directions that bear no immediate weather. Its seafloor generates tremors and hydrothermal emissions, and the slow processing of plate convergence that build the arc and sustain its volcanic activity. Its typhoon season arrives each year without announcement and proceeds through its sequence of developing storms with the same regularity that the season has always shown. All of this continues at night as it continues by day. The dark does not interrupt it. The absence of observers does not change it. The zone does what it does in the same way that any sufficiently complex region of the natural world does what it does, according to its own physics, on its own timescales, indifferent to the significance that the people crossing it have assigned to it over the centuries. The Japan Meteorological Agency's Typhoon Track Archive for the Western Pacific covers more than 7 decades now.